Hello all, welcome to my course on methods of adhesion measurement theory and practice. Today we are on lecture 30 and today I am going to start a slightly different method of measurement of adhesion, and this I have taken from this particular paper by Waters et al. And on adhesion enhancement due to concave surface geometries. So, here today I will discuss about an adhesion of a rigid punch with convex head on an elastic half space. So, convex head is essentially a spherical type. So, we will discuss the convex indenter today, and then in the next few lectures I will discuss about concave indenter as well. And the convex indenter I will see that we will not derive it using the Hertz mechanics, the Hertz approximations that we will not do that, and then we will but we will use this idea from fracture mechanics to derive the expression for work of adhesion, and we will use use a theory developed by Abel for determining the pressure distribution. I will just go into it right away. So, yeah, convex indenter, this looks like this. So, basically it is a rigid punch, but here these approximations of the Hertz mechanics, that what is the radius of this indenter is much larger than the contact area, those approximations are not required. Okay, it is like that. So, nevertheless it is frictionless contact that will consider. So, this rigid indenter is pressed against this elastic half space. So, we will like to know what is the kind of pressure distribution in the loaded area of this elastic half space. We will also derive the expression for work of adhesion, and then I will like to see that whether we can get back to the results of Hertz mechanics and also the JKR contact mechanics. Okay, we will do that. Now, here remember this is an axis symmetric indenter. So, from the top it is a circular looks like a circle, and therefore, it is very close to the spherical contact that we considered when we discussed about JKR contact mechanics. So, this surface of this the height of this curved surface from this surface of the elastic half space when there is 0 load can be represented by z is equal to r square by r. So, at r is equal to 0, this z is equal to 0, at r is equal to r, this is height is capital R, like that. So, this is at a 0 load. Now, we apply some finite load, let us say it is P that has been applied. Because of that, this indenter presses against this elastic half space. So, there is deformation, and in the elastic half space it comes in contact with the indenter within this region. So, the width, the diameter of this region is 2a, radius is a, and this location where this separation occurs or the contact line separates or contact happens, it is actually h. This distance is basically h. Okay. So, basically it is a spherical indenter, not spherical head, indenter having the spherical head that presses against it. So, now this vertical displacement from the surface surface of this elastic half space, that is this V. So, V at any r at z is equal to 0, that defines the vertical deformation of the elastic half space, right. So, that I can write it here as a plus b square, where a and p we can find out. So, for example, that the indenter has gone inside or has pressed this elastic half space by a distance delta here. So, therefore, I can write it that at r is equal to 0, this so v at r at z is equal to 0. Okay. So, this is equal to delta, here, and at r is equal to a, this v at r at z is equal to 0, this is equal to how much? So, this is actually this distance. So, this distance will be what? Delta minus h, that is delta minus h. So, therefore, if we substitute here it will be delta, okay, that will be equal to A, because r is equal to 0, delta is equal to A here, and here it is delta minus h, that is equal to A plus B r square. So, A is equal to delta, so gets cancelled here. So, S is capital, this r is equal to A, so it is A square here, r is equal to A, so it is A square. So, capital B is equal to minus h by A square. So, therefore, this V r at z is equal to 0, that will be given by delta minus, this is h by A square into r square. I hope this captures this idea. So, this V at r is equal to 0 will be given by this delta minus h. So, at r is equal to 0, this is delta here, that is fine, and at r is equal to A, this is delta minus h. So, delta here and this minus h here, that is fine. So, this is the way. Now, how does one solve these problems? So, that is solves the problem, as I said, by using what is known as the Abel integral. So, here there is a unknown function, sorry about this, here it is actually g1 r that is defined. So, there is an unknown function g1t, let us say g1t that is found out by using this equation, okay, that is the way it is, that Vr depends upon this g1t function. And how this g1 is obtained? The g1 is obtained by integration and then this differentiation, okay, by basically this expression. So, these expressions are derived by mathematicians like Abel, and we will not worry about how they have been derived, but we will use these results for obtaining our solution, that is how we will do it. So, here the expression for g1 that we derive, that we substitute over here, and then we do again the integration and then differentiation and obtain this pressure distribution. So, that is the way it is. So, looks quite laborious, but it is not that laborious. I will do it for at least 3 different profiles and I will show you that yeah, it is quite nice doable. And finally, this total indenting force, that is P, that is given by this expression. So, once you have found out G1, you can find out that. So, now see here that we have the expression for the V1 as a function of r that we have, and by using this equation we can find out this integral. Differentiate this integral by s, then you have the expression for this function, unknown function, okay, this is called G1s. And once we have that, then you substitute it over here and then obtain this pressure, that is the way it is. So, let us try this. So, here I have already derived the expression for V. So, here it is derived as V equal to delta minus h and r by A square, that I have derived already. And so, here we will substitute the expression for V, okay, into this. So, r into Vr, so let us say r into V at z is equal to 0, okay, that will be given as delta into r minus this is h and this is r by A whole square, like that. So, yeah, and then we substitute that, yeah, basically that, and so here it is minus E square by pi, this is d by ds, okay, let us say I call it I, and then my I is equal to 0 to s, and this is r into Vr into this quantity. So, this is basically r into delta minus h by A, this is r cube, and this is square root of a square minus r square, and this is dr. So, yeah, like that. Now, let us say that yeah, I have to integration by substitution. So, let us say a square minus r square, let us say this is equal to t square. So, then at r is equal to 0, so let us say minus 2r dr is equal to 2t dt here. So, 2 gets cancelled. So, I have to take care of minus sign here, and then I have, let us say, yeah, so at r is equal to 0, r is equal to 0, t is equal to s, and r is equal to s, t is equal to 0, like that. So, anyway, let us see, I will substitute back with s and I will not go into that now, right now. Okay, so here I have minus 2r and dt. So, here therefore, this I will be equal to, let us say it is 0 to s, and this r dr, so it will be minus, this is t dt and divided by a square root of a square minus r square, so it is t here, and then minus, this is 0 to s here, and this is h by a, and this is r square. So, r square will be equal to a square minus t square, and it is r into dr. So, that will be equal to t into dt, and this is with a minus sign of course. So, this minus minus, it will be plus here, okay, and then it is t here. So, it is minus, so minus minus plus here, and here this is delta here. So, here r into delta, so r here, so r dr is equal to minus t dt, so minus here, that is correct, this is correct, and this is correct here, and so therefore, I can write it here equal to minus delta, and this is t. So, t is equal to, remember, square root of a square minus r square. So, it is square root of a square minus r square, and then plus this is h by a, and then here it is s cube by this is a square into t minus t cube by 3 here, right, and then here I have to substitute t back into in terms of r. I will do that right away. This is s. So, here for example, this is 0 to s here, this is delta. So, it is minus delta square root of a square minus r square 0 to s plus this is h of a, and over here this is a square, and instead of t I will have square root of a square minus r square and minus 1 by 3, and the t cube will be a square minus r square in 3 by 2, and the whole thing will have 0 to s. So, that is the way this integration can be done, and here it is r is equal to s, so it is 0 here and minus minus plus here. So, delta into it will be 0, so it will be s here, delta into s plus it will be h by a, and here it is when r is equal to s, this is 0 and minus, therefore, this is a square and r is equal to 0. So, it will be s will come out. So, s into s minus half, and here r is equal to s, this is 0. So, minus minus plus here, it will be a square half, so it will be s cube here, right. So, like that. So, minus s cube plus s cube, so I will get half of s cube here and like that. So, let us see what final result I get. So, finally, I get here delta into s minus 2 by 3 h s cube. So, I guess here this 1 by 3 was there. So, I guess I missed this 1 by 3 looks like here it is 3 cube, it should be 2 3 here, not 2 here. So, yeah, you can correct it. So, here it will go like that. So, then finally, this g1x comes out to be this expression, and this now can be used for the 5 to substitute here. So, I will substitute here. So, it will be 1 by r, and this is minus. So, minus over here, this is E star over delta, sorry, E star over pi, and this is d by dr, and this is r to a, and this is t into g1 of t. So, t into this is delta minus 2h by a square, and s in terms of s, that will be t here. So, it is t square. So, it is a square, so t square here, this is dt here, and square root of this is t square minus r square. So, we have to now do this integration over here. So, we can do that. Let us say that here this I is equal to r to a, and this is delta, and this is t by square root of t square minus r square into dt minus this is 2h by a square into r into a, this is t cube by square root of t square minus r square dt, like this. So, here again let us say I take t square minus r square, t square minus r square some z square. So, here it will be equal to 2t dt is equal to 2z dz. So, 2 into t. So, 2 gets cancelled. So, t into t will be z into dz. So, here I will have delta into r into a. So, t into tt is equal to z into dz over z, and minus this is 2h by a square, right, minus 2h by a square, and here it is r to a into t into dt will be z into dz. I will have t square here. So, t square will be r square plus z square, r square plus z square, and t square minus r square is equal to z here. So, this z gets cancelled. So, it is not that difficult actually, you see. So, this is this. So, delta is equal to dz, you integrate it, it will be z here. So, the z we replace by square root of t square minus r square. Those integration has to be done with little concentration, that is it. This is r here, this is a here. So, instead of z here I am substituting here square root of t square minus r square minus 2h by a square, and here it is r square into z. So, r square into z means it is square root of t square minus r square and plus, and this is z square here. So, it is 1 by 3 z cube. Instead of z cube I will write this t square minus r square to the power 3 by 2, that is it, and here it is r to a, that is it. So, now it can be simplified here, delta is equal to, let us say it is square root of t square square root of t square, yeah, t square minus a square, t square minus a square, t square minus a square. So, instead of t I will write r, right. So, yeah, so it is correct. So, it is sorry a square minus r square, sorry about that. It is square root of a square minus, because in place of t I will write a. So, it will be a square minus r square, and therefore, it is minus 2h by a square, okay, and this is means in place of t I will write a. So, it is r square here and square root of a square minus r square plus 1 by 3 here, I know. So, plus, okay, let me see what will be if I write t is equal to 0, that is fine, plus 1 by 3 here, and instead of t here I will write a here. So, it will be a square minus r square to the power 3 by 2, that is it. So, that is what we will get here, this quantity I. So, this I has to be substituted there, and so therefore, I have done all that here, yeah. So, I have gotten this. So, here finally I have it here, yes. So, delta into a square minus square root of a square minus r square minus 2h by a square into this quantity plus r, this I have gotten already. So, here now I have this. Now, I need to find out the derivative of that quantity with respect to di by dr. So, I have to find out di by dr. So, dir by dr. So, that is equal to delta, and this is 1 by, it will be square root of a square minus r square, and this is here minus 2r minus 2h a square, and over here let us say it is 2r into square root of a square minus r square plus r square into square root of a square minus r square to the power 2 minus 1. So, I hope I am doing it correctly, right. A square minus yeah, so it is okay. So, it is square root of half. So, I think half has to be there here, half here, and it is 2r r into this. So, r square. So, it is half here, okay, and this is minus 2r here, and plus it is 1 by 3, and this is 3 by 2, okay, and here it is minus 1. So, it will be a square minus r square and minus 2r. So, therefore, minus it is delta by r square root of a square minus r square, and minus this is 2h by a square, and then we can further, which I have done here. So, here I get minus delta r by square root of a square minus r square, that is fine, and from here I get here 3 gets cancelled, and square root of a square minus r square square root. So, if I multiply yeah, that is fine. So, it is 2 also gets cancelled. So, minus r here. So, we need to take all these points together now. So, we will get here these two terms r r into a square minus okay, that's fine. Let's see what we get. We get r into square root of a square minus r square minus r cube into square root of a square minus. So this r cube we get from here. So 2 gets cancelled. So I get here minus r cube into square root of a square minus r square, and from here I guess there is a there should be square root here because it is minus, yeah, square root here. So this square root and this square root will cancel, will multiply, and so finally we will get here something like this. So here I will get this solution, and then I can write therefore divided by 1 by r. So we get p of r is equal to minus E star by p, and then like this. So you substitute over here. So we will get minus E star by p 1 by r and minus delta r by square root of a square minus r square. So this is this quantity, and from here I will substitute over here. Finally we get take the square root of a square minus r square out here, and then you get here delta plus this quantity. So basically this is the final pressure distribution that we get in this in the contact area. So yeah, so like that you get. So since this is pressure distribution P of r, then the normal stress will be negative of that. So it is minus, therefore it is minus, and you get like that. We can also estimate what is the total load that is applied. So you have to multiply this P of r by 2 pi r. So it will be 2 pi and integrate between 0 to a r into P r. So it is r into, so it is E star, this is pi into square root of a square minus r square. Now multiplied by r, so it is delta into r plus this is 2h by a square into a square into r minus 2r cube whole thing dr, right. So it is delta into r plus 2h by a square into r, so a square r minus 2r cube dr, good. So this is equal to, therefore this is equal to 2 pi into this is E star by pi. So pi gets cancelled here, and then I have here, let us say delta into 0 to a, this is r into square root of a square minus r square dr plus this is 2h by a square, and then I have here 2h by a square, and then I have here this is a square into r by square root of a square minus r square, and then I have minus, let us say it is 4h by a square into this is dr here into this is r cube into dr by square root of a square minus r square, all the cases 0 to a here. So here 2 pi E star by p taken out. So delta here r by square root of a square minus r square, and then here it is 2h by a square. So let us see this a square, I tell it outside. So a square gets cancelled. So I have here r by square root of a square minus r square dr, that is correct, and minus 2 here. So minus 4h by a square, and then it is r cube into r, and like that. So here if I do, it will be 2 E star into this is delta, and this integration has to be done. So it is, you take it again, a square minus r square is equal to some z square. So it will be z here, r there. So let us do it. No, r is equal to a sin theta, we have done it. Okay, that is good. R is equal to a sin theta. Let us substitute that. So it will be r sin theta. So dr will be a cos theta d theta. So and r is a sin theta. So a sin theta here, and this is a cos theta here, and here it is a sin theta. So dr is equal to a cos theta d theta. So a cos theta d theta here. Okay, and now this is not delta plus 2h together. Okay, because I do not need to do it twice, 12 to 2h together, minus this is 4h by a square, and here it is 0 to a. So this is a cos theta. Okay, here it is a cos theta d theta, and r cube is is a cube sine cube theta, okay, and at theta is equal to 0 you have r is equal to 0, so r is equal to 0, so theta is 0, so it is 0 here, and at r is equal to a, theta should be pi by 2, so let us write it between pi by 2, right, looks good. So this gets cancelled, and so finally I have 2 E star into delta plus 2h, so this also gets cancelled, so it is delta plus 2h, and this is a here, and this is minus cos theta, right, d sin theta is minus cos theta, this is 0 to pi by 2 minus this is 4h by a square into a cube into sine cube theta. So sine cube theta we have to use sine 3 theta formula. So let us say I have 4 here, so it will be 0 to pi by 2, so 3 sine theta minus 4 sine cube theta is sine 3 theta. So sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, so 4 sine cube theta will be 3 sine theta minus sine 3 theta. So it is 3 sine theta minus sine 3 theta, okay, into d theta. So you do all that. So this is this a gets cancelled. So finally you will have 2 E star, okay, into delta plus 2h into a here, and pi by 2 is 0, so cos 0, so this is fine, minus cos 0 is 1, so this is h a, this is h into a here. Now what do I get here? So this is 3 here, okay, and sin theta means minus cos theta, so again I will get 0 minus 1, so I will minus cos theta, no, so minus 1, so I will get 1 here, right, I will get 1 here, and minus it is I think this term it will be cos 3 pi by 2 and cos 0, so that will be minus 1, so I think this will get cancelled, most probably it gets cancelled. So I will have delta minus h like that most probably, but let me see the whole thing that I got finally. So here it is 2a cube by 3, so finally I will get here this expression delta plus 2h for this side, and I will get here minus 4h by a square into 2a cube by 3, so it comes out to be e star by 2 e star by a into delta minus 2h by 3. So the calculation I have already done here, I was trying to do it anyway over here. Here I will get yeah, so the pressure, okay, comes out to be like this. So I will continue with the discussion on comparing this result with Hertz mechanics in the next lecture. Thank you for your kind attention.